Hello, good morning. Uh, Today I am going to represent pre-PhD coursework seminar on the topic of effect of metalloidoping porous nanoferrite and catalytic properties in Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, and research center is Jawahar Art Science and Commerce College, Andur. For the degree of Doctor of Philosophy in Chemistry by Miss Pranita Lomte, and research guide name is Dr. Mallinath Maruti Langde, Department of Chemistry, Jawahar Art Science and Commerce College, Andur, District, Usmanabad. Outline, introduction, several techniques for the synthesis, sol gel method, applications, flowchart of sol gel method, synthesis of nanomaterial, characterization and results, objective, conclusion, and next is references. In introduction, first is nanomaterials are the material in which particle size range from 1 nanometer to 100 nanometer. Study and uses of this particle called as nanotechnology, material having unique properties arising from their nanoscale dimension. Nanomaterials with fast ion transport are related also to ionics and nanoelectronics. Nanoscale materials can also be used for bulk applications. Nanomaterials are something used in solar cell with complex the cost of traditional solar silicon cells. Ferrites are significant family of magnetic materials that have become much more significant in the last several years become of their numerous application in electronics, magnetic recording, communications, and microwave absorption based devices. Next is numerous preparative techniques have been developed in an effort to synthesize the nanostructured ferrites nanomaterial with tunable magnetic and electrical properties, controlled morphology, controlled microstructure, high purity, and improved homogeneity. Material science research is primarily concerned with the investigating new materials with optimized properties and innovative synthesis techniques. Mixed oxide with a spinel structure from an extended series of metalloid solutions and have valuable properties. Due to its high magnetic permeability, high electrical resistance, and low production cost, many ferrites have been used in various electronics components for a long time. Uh, in this nanomaterial, preparation of nanomaterial, there are several techniques for the synthesis of nanomaterials. Uh, there are various methods such as physical methods, chemical methods, biological method. In physical method, there are several methods. In biological method, there are several methods like microbial, plant, algae, biomimetic, etc. But in chemical method, there are Solgel method, solothermal method, co-precipitation method, chemical reduction, and so on. There are, but in this preparation of a nanomaterial, Solgel technique is very uh, useful, very fast technique. And in this Solgel method, time consume is less. So this Solgel method is uh, I can use. In this social method, the preparation method is as below. There are various stages are arising. There are preparation of the soul, gelation, aging, and drying. So, in preparation of a soul gel, in preparation of the soul, The initial stage involves the creating a colloidal solution, means formation of a sol by dissolving precursor, typically methods alkoxide or metal chloride in a solvent. Hydrolysis and polymerization reaction occurs when the precursor react with water, forming a network of interconnected particles. Next is formation of a gelation, means formation of a gel. As the reaction continue, the sol gradually transition into a gel-like network coating both liquid and solid phases. This process is given by the further hydrolysis and condensation reaction, leading to the formation of a three-dimensional network. And then next stage is aging. The gel undergo aging, the period during which the network continue the recognize the strength in during aging synthesis. The explosion of solvent from the gel can occur, leading to further densification of the gel structure. And after the formation of aging, next step is drying. The gel is then dried to remove the remaining solvent. Depending on the drying method, this can result in different types of method. We have I have take the some application for the Solgel method. We know that Solgel method have the various application like ceramic and glasses, coating, catalysis, optical material, and nano materials. In ceramic and glasses, in this producing high purity and homogeneous ceramic and glass with complex composition. In coating thin film coating for various purposes such as anti-reflective coating, protective coating, and decorative finishes. In catalytic synthesizing catalytic material with high surface area and control porosity. In optical material, fabricating materials for optical application like lenses, waveguides, and photonic catalyst. In nanomaterials, producing nanoparticles and nanocomposite with controlled size and distribution. For the formation of a nanoparticle, the in social method, the flow chart I have taken for the flow chart. In this method, we have first take the mixture of a solution like ferric nitrate, lead nitrate, or etc. means mixture of a solution plus citric acid. We have stir for the solution for 1 hour. After stirring, we have addition of ammonia to maintain the pH. We have added the ammonia. Like we have if we have can if we have can take the reaction, we have process the reaction is acidic form, basic form, and neutral. We so maintain the pH and then stirring the solution for 900 degrees Celsius for 1900 degrees Celsius for 4 hours. Then formation of gel. Solid product is formation, then calcinated at 700, 400, 900, and so on for 5 hours, 6 hours, or so on. And then sample is prepared, then calcinated the characterization the sample. After characterization, we have take the result. My first thing is synthesis of a metalloid doping nanoferrite. My scheme name is indium doped lead nickel ferrite. Uh, so synthesis of a nanoparticles through the sol gel method. We have see the sol gel method like precursor, dissolution the sample, solution as a source for spin coating, sol gel spin coating, then formation of a sol gel dip coating, then substrate dipping into the solution bath, and then dry as a powder and calcinated, then formation of nanoparticles. During the formation of nanoparticles, I have take the some images of a reaction. Uh, Firstly, I have take a beaker, and then I have add the some solution of lead nitrate, nickel nitrate, ferric nitrate, lead nitrate, etc. And then addition of stir it for 1 hour, then addition of ammonia to maintain their pH. I carry my reaction is carried out at neutral. So we have I have maintained the pH is 7. So after maintaining the pH, then heating is started for 900 degrees Celsius, 90 degrees Celsius, then formation of a gel. Then after the formation of gel, I have removed the needles, and then heat the solution. Then the formation of a powder. Then the sample was crushed and characterization for various techniques. During the formation of a nanoparticles, the material have been characterized by various methods. Characterization of supported materials such as UV visible absorption spectroscopy, thermochrometric analysis, X-ray diffraction, scanning microscope, transmission, dynamic light, DLS, and energy dispersive X-ray, ED, AX, etc. So I have firstly characterized the indium doped lead nickel ferrite is sent to the sample for the characterization of thermogrammetric analysis. So I was obtained the reading, and I have plot to the graph temperature versus weight. Then I have observed that there are various laws in the figure. First loss, then second loss, then third loss, then in this picture I have decided to sample was heating at after 70 to 9, 700 and 900 degrees Celsius for 5 hours, because I have some queries. So after the conclusion of this graph, we have uh, take the result. The resulting powder sample of indium doped lead nickel ferrite was examined by TGA for the removal of impurities and observed the initial decomposition of indium doped lead nickel ferrite is obtained 440 degrees Celsius and 170 degrees Celsius due to the removal of observed water, and the initial ions is 0.90%. The second decomposition indicates that the uh, temperature difference between 171 degrees Celsius and 340 degrees Celsius is primarily due to the loss of other residual and other impurities during the synthesis, namely, and excess of the nitrates with the secondary loss of 2.02%. The third loss is due to the presence of excess of ammonia solution is appeared between 341 degrees Celsius to 620 degrees Celsius, shows 1.74% weight loss. The final decomposition exhibits the formation of a metal oxide between 621 degrees Celsius to 900 degrees Celsius. Thus, the synthesized material shows thermal stability. So, samples were calcinated at different temperature, 700 degrees Celsius, 400 degrees Celsius, and 900 degrees Celsius. After calcinated, we have deciding the sample were calcinated at 900 degrees Celsius for 5 hours, and then the sample was sent to the X-ray diffraction. I was obtain the some readings, so I have plotted the graph. of XRD, X-ray diffraction of the sample, 2 theta versus intensity. So I have get the some mirror indices and peak is observed like 110, 111, 200, 211, 220, 300, 311, 400, 421, 422, 520, 440. Figure shows the XRD patterns of synthesized ferrite nanoparticles. The X-ray diffraction pattern shows the diffraction peaks 110, 200, 211, 220, 311, 400, 421, 520, 440 for all concentration samples. The most intense peak was observed at 311 for this sample. So 311 is the peak of ferrite sample. So we can see we can see the 311 is a ferrite peak. So sample is prepared very purely. A similar XRA pattern has been observed in the literature. Thus, the obtained pattern confirms the spinel ferrite is pure from the crystalline in nature. After the XRD pattern, we have conclude the sample is formation of a ferrite is very pure. So I have sent the sample uh, same and EDS. So resulting pattern will be uh, due in some days. A series of ferrite was prepared through the soldier autocombustion method. The device skimmer equation is used to calculate the average particle size, which range from uh, 25 to 27 nanometer. The scalar formula was used to determine the crystalline and particles. So the XRD diffraction I was sent to the sample uh, same and EDS. So next plan work is to study the newly prepared sample by using characterization to study the shape and size of nanomaterials by using XRD analysis to investigate the thermal stability by using TGA to study the morphology of nanomaterials by using FECM techniques to study the uh, elemental determination of a nanomaterial by using EDS technique to study the magnetic properties by using VSM to investigate the surface area of the nanomaterial by using bait techniques to investigate the material behavior of nanomaterial by using VSM to investigate the dielectric properties of nanomaterials to study the microbial activity and anti-cancer activity, etc. And investigation of photocatalytic studies towards population control types. Next is objective. Uh, to synthesize the nanoparticles with high surface area using Solgel method to prepare new spinel ferrite nanomaterials to design new methods to characterize the characterization the supported nanomaterials by using techniques such as XRD, TAME, SAME, STM, AFM, UV visible, FTIR, BET, etc. Particularly, utility of designed nano-sized catalysis in methodology development dyes degradation by eco-friendly routes and references. I was collected some reference books and reference books such as given below. And thank you.